And good morning from our Boston Regional Training Center here. This is in Nashua, New Hampshire. I'm Matt Schwegler with ITC. Thank you for joining us for today's live tutorial on the basics of IR roof moisture surveys. On the line with me from his home office is Bill Schwan. Bill is one of our ITC instructors. He's an ITC level 3. He's also our go-to trainer for SUAS and aerial infrared. Bill's been with us for a number of years, and he's gracious to join us today from his home office to present on the basics of roof moisture surveys. And I think he's going to touch on a little bit of UAV in this, but we'll talk about all the basics of doing a roof moisture inspection. Good morning, Bill. How are you?
Good morning, everyone. How's everyone doing this morning? Hopefully well. Thank you, Matt. And again, just touching base today on the application of infrared thermography to roofing systems. So we'll just kind of go through this and look forward to any questions you have. And of course, if you can always email me at william.schwan, SCHWAHN, @FLIR.com. So roofing inspections are rather unique. Again, my name is Bill Schwan, level 3 thermography instructor and FAA 107 RPIC, along with Matt Schwegler today. So I'm going to talk a little bit here about the applications of different things that we can look at while we're doing a roofing inspection with thermography. But we'll just take a quick look, just a brief introduction here, just some images. We'll go through some images today. We'll look at some different applications. So really, what is thermography? We have to kind of talk about what that is as well. If you look it up on Wikipedia, you're going to find that thermography is a lot of different things, including a printing process. But it's basically an analysis tool, a process of acquisition and analysis of thermal information to give us more direction on what we can do or what our evaluation might be for resolving conditions. If we look at this image here, you're going to see two images. American flag, and the American flag on the left, American flag on the right. If you look at these two images, there's something distinctively different in these images that really applies to roofing and roofing thermography. And the image on the left was taken outdoors. The image on the right was taken indoors. And so we have to talk a little bit about solar absorption, solar reflection. All those things are impacting what we see when we do an infrared image or a thermography inspection on a roof. Next image, a little bit humorous here, but really this does apply as well. Thermal capacitance of different items and evaporation. The thermal capacitance of the objects underneath the roofing membrane to retain energy. And those assist us in determining where the moisture might be located or where there's structural issues as well, installation issues. So evaporation and thermal capacitance play a factor as well as solar absorption. If we look at thermography, there's a lot of things that surround thermography, if you want to put it that way, and analysis techniques, camera handling, thermal science, applications. Our inspection routes and how are we going to report what we see is very important, and we'll touch base on this as well in this webinar. And radiation science. As you can see, there's a lot that goes into thermography. It's not just taking the image. That might be an easy part. So if you really want to learn all these different factors, including the impact of thermodynamics on what you see, we would recommend you take a ITC level 1 or roofing course. It goes into all of these different aspects of thermography so that we're doing it the correct way and we get great images. We'll just touch base here a little bit into roofing materials, structure, and water intrusion. So we'll look at some images in this section. I took this image several years ago, but here we've got some moisture underneath a membrane, and this is a walkout deck over the top of a living area. And you can see the area that's kind of circled in black, that's moisture, but you also see that moisture wicked up into the exterior cladding. If you also look, we see fasteners. Fasteners can tell us whether there's proper nailing at the roof structure or how it was installed. This next image is, again, the same basic roof deck, but you can see that the water intrusion here is much different. Now, this was taken just right after the sun was off of the membrane. So it was in the summertime, and there's always that question: when is the best time to take an infrared image on a roof membrane? And the answer is really basically after solar loading is off of that membrane. And we'll talk about some other conditions that are necessary. But here you can see that there's some delamination of the coating that's on top of the roof, and that does not really present itself. The little specks that you see here are basically some specks of rain or moisture that was had come onto the roof for about 5 minutes and then left. Roof drains. Here's a commercial application, and you can see roof drains staining in dirt will look just like maybe probable moisture underneath the membrane. These are always potential areas because you have a solid object in the roof drain, and the flange around it is solid, yet the roof membrane itself flexes. So this is a typical area of water intrusion. Roof surveys from an SUAS or unmanned aerial vehicle. We'll talk more about this as we go through the webinar, but you'll see that there are some areas here as well where this is a much faster way to look at large roofs, 400,000, 500,000 square foot roofs. It's much easier to plot this out and map this out from the air than it might be from walking it. So when we typically look at roof membranes, our primary objective is let's find the moisture, find the water under the membrane. But other things that we can do with this is evaluate the application. Here you see side laps, you see end laps, and you also see fasteners. So the question becomes, did we overlap it correctly? Was the nailing pattern correct? And you do see some irregular nailing pattern in this image. And these are things that we can see when we do thermography on a roof. Here another image, potential areas, overlaps, seams, and joints of water intrusion. And you can see the visual and the IR image here. Here the thermographer mapped it out and painted it and gave it a number so that we could identify where this location was on a mapping system. But you can see that these are also potential areas of water intrusion. Seam leak on black EPDM. There's a lot that goes into thermography, but if you look at this, you can see that there's probably 4x4 sheets of insulation or 4x6 sheets of insulation that might be underneath this membrane. It's definitely following the moisture pattern here in grayscale is definitely following a pattern of the seam or following the pattern of the insulation board underneath. It's important to look at different types of color palettes. Color palettes just give us a different perspective. Iron bow is used a lot. Grayscale can give us great spatial detail and allow us to see a lot more, many times a lot more than iron bow, because it just gives us greater detail. Again, another image here, of seam overlap. Are the seams overlapped enough, or they overlap too much? Or how was the installation performed? Here you can see also some securing fasteners that are underneath the membrane. Sometimes you can also evaluate the structure and see structural components underneath the membrane. Here we see a cricket And that cricket, of course, is used to divert water. And it all depends on mass. The mass of the object that's underneath will allow it to absorb more or less solar load, and therefore it will look different underneath the membrane. So this is kind of an interesting image that's, sometimes we're just looking for water, but we want to be more detailed and see more things like structural components, nailing patterns. In this image too, you can also see several different nailing patterns here, and the nailing patterns are very irregular. They're just a little bit of everywhere underneath this membrane. You can also see the seam going right over the top of the edge of the cricket. And so you really need to know a lot more about the roof before you start doing thermography. Talk to the building engineer, find out what type of membrane was on, type of insulation underneath, when it was replaced, any history of roof leakage. All those things can help you be more successful when you're doing thermography. So it's a good thing to really do the evaluation before. And of course, safety is always important. If you look at this roof, there's not much of a parapet wall here. So we always recommend what's called the 360. The 360 means that we walk the entire roof and look 360 degrees in all directions to see any hazards. The other thing it does is it allows us to identify where reflections might come from other structures that would be impacting down on this roof and give us false readings, false infrared images that may look like moisture, but really are reflections from another target next to or around this building. So doing a 360 evaluation prior to doing your thermography and finding out everything about the structure is very important. Low thermal contrast, also known as thermal equilibrium. There's not much difference here between the moisture underneath the membrane and the membrane itself. Of course, one of the things we have to have if we're going to do this and be successful is we have to have the perfect conditions. So the perfect conditions might be a clear, cool evening. So the coldest thing you'll point your infrared camera at is the sky. You actually see into the atmosphere when you point it at the sky. It's not unusual on a clear, cool evening to get numbers in the negative Fahrenheit. So it's important that right after solar load or later in the evening after the sun is completely down, that we have a cool, clear sky with very little cloud cover, because that's going to give us the greatest delta T between the heated water under the membrane and the sky itself. So perfect conditions, those would be an example of maybe really great conditions. Of course, there can't be any water on the membrane, so that's important as well. Make sure you get a good understanding of the structure, roofing materials, because they're going to be different between residential and commercial structures. Making good decisions are just based on knowing your components, knowing your roof membrane, being safe up there, and knowing the perfect conditions in order to perform roof thermography. I've always said roofing thermography is more challenging than a lot of other applications because, of course, there can't be any moisture on the roof. Doing it in the morning, there could be condensation in the roof. Condensation warms the substrate, and then it cools and it makes it difficult to see any moisture underneath. So all these conditions can be very challenging. So finding that perfect day is not as easy as you may think. Now, here's some challenging infrared images, things that maybe you have or have not seen. Interesting image here. This was on a roof, and there was some speculation that there was water in these areas. And if we did, when we did the evaluation inside out and talked to the building engineer here, we found that there was very little area between the inside ceiling and the outside roof. And what you're actually seeing here is the lights inside the structure. Of course, these are very symmetrical, and water usually isn't symmetrical, but interesting image here of a roof that's presenting energy, but energy from within the structure. Uneven ballast, graveled roof. So these roofs are very challenging because depending on the gravel, of course, the gravel or the moisture or the dirt will hold the moisture and make it harder for us to see exactly where whether the thermal anomaly is actually moisture held by the gravel or thermal anomaly with the moisture underneath the membrane. Ponded water, is there a leak? Well, not yet, but a good probability. Remember, you can't image through standing water or condensation that's on the roof. Here's a good image of some ponding water. Of course, the ponding water looks blue in nature, and what this ponding water is reflecting is the sky. So it's really important that there's no moisture on the roof, condensation on the roof. As you've seen in the earlier images, you can see the raindrops. The cameras are sensitive to pick up the difference between moisture and the actual water underneath the membrane. Some methods of inspection: walkover. There's three basic methods. Walkover, just as we've been talking, infrared camera, you walk over the roof, and you have to make sure that you have the correct angle, and if you don't, you're going to see more reflections than you're going to see thermal anomalies. And that's what we call them. We call them thermal anomalies till we can further evaluate them with a moisture meter, make sure what's going on under that membrane. Walk under. This is where you have access to the underside of the roof. And of course, what you're looking for here is a cooler thermal anomaly where water is presenting itself through the membrane, and then aerial. And one of the things that I haven't really brought up yet is in doing our homework, we should also understand whether the structure is positively or negatively pressured. This does have an impact on what we're going to see on the roof. For example, if it is negatively pressured, there's a good possibility that that is pulling moisture through the leak in the membrane and into the structure. So knowing whether your structure is positive or negative pressured is really important. In aerial, SUAS, from the air, evaluation from the air. These are the three basic methods of inspection when we're talking about doing roof inspections. Aerial has become one of the greatest applications right now. If you're interested, check out Zenmuse XT 640 by 512. That's one of the most popular cameras. The new XTR camera is also very popular in that it has visual and infrared in the same camera. And what this allows us to do is take visual and infrared images from 300, 200, 150 feet above the roof. And remember, when you do this, there's also FAA 107 regulations that you must, if you're going to do this commercially, we strongly recommend that you read the regulations, understand the regulations, and what flight area you're in so that you're in compliance with all FAA regulations. Another image from the air. Again, you can see it's very easy to see an entire roof membrane, depending on size, in the potential areas where there might be moisture intrusion or structural deficiencies. So from the air makes it a lot faster. You've got a great contract, a 300,000 square foot roof. It's going to take you a while to do it with a walkover method, but with a flyover method, it's much faster, and you can see some great images, as in this image. You see the visual image on your left. On the right, you can see areas of potential water intrusion. So walk under or flyover is a great way to do it. Of course, when we get those images, one thing we have to look at is what are we going to do with them? We recommend FLIR Tools. Of course, FLIR Tools is a radiometric software. Radiometric meaning that when you take an infrared image with an infrared camera, it not only captures the visual part, it also captures temperature. So in order to extract those temperature readings or to thermally tune the image, you're going to need a radiometric software. FLIR Tools fills that. Is a great software to fill all those applications. Two different versions. FLIR Tools has a free version. FLIR Tools allows you to create reports, infrared images, visual images. Of course, that's a radiometric program. And then there's FLIR Tools Plus. Now, you can also get a 30-day trial with FLIR Tools Plus. The fee is $295. That's a one-time fee. You don't pay it again. You get 2 licenses with FLIR Tools Plus. And I've also put the website below for you. So if you wish to take a look at that website and use the trials to see if it works for you, that's fantastic. The biggest advantage to FLIR Tools Plus, in my opinion, is that I can take multiple images of a roof membrane and I can stitch them all together into one image. And it maintains all the radiometric value. So now I can see the entire picture instead of just one picture or 2 pictures and tagging through them all. I can stitch all these images together and get the entire idea of how large the moisture intrusion is. So that's a real benefit, in my opinion, to the use of FLIR Tools. If we're going to do thermography on roof membranes, we strongly recommend that you research and get a copy of ASTM C1153. This is the recommended standard for performing thermography roof inspections. It deals and goes into a lot of detail, so we encourage you to get this. Some of the things you'll note in there is the time of the day to do this, the delta T, the minimum delta T necessary in order to perform inspections, the minimum wind or the maximum wind speed that's allowed to get good images. Of course, that's something that we have to be aware of as well. There's too much wind, we're not going to be able to see the thermal anomalies under the membrane. So we encourage you to get a copy of ASTM C1153. Different IR cameras. And this, we just touch base because I get a lot of questions. As a matter of fact, I just had a person email me yesterday. Hey, Bill, I'm getting into the roof inspections. What cameras should I use? Of course, there's a lot of different things to look at. The T500 series is an amazing camera in that it's all touchscreen. Very easy, simple to use, and it's very lightweight. Some priorities are things you might wish to consider when you're taking a look at different cameras. Resolution. The higher the resolution, the more information is provided, and the more you'll be able to resolve thermal anomalies. So the greater the resolution, the better the image. Sensitivity. The more sensitive the camera, the smaller the temperature difference can be resolved. So that's really important as well. And for me, it was always productivity. How easy is the camera to use? Can I change the lens position? How large is the screen? Is it touch screen? The easier the camera is to use, the more productivity I get out of it, the more membrane I can take a look at. And again, Matt's kind of touched base on this, but training is very important. What's the proper conditions to have to really get the best out of it? What is the science behind what the camera actually sees? Those are questions that we answer and direct in the IR roofing training course. And it's a 2-day course. And we've been very successful. This course has been very successful. Average student count has been somewhere between 25 and 30 people per class. And again, it's a 2-day course, and we encourage you to investigate that too. Don't forget ITC web-based courses, camera operation, building basics, home inspections, indoor electrical, outdoor electrical. IR training also has some great forums for you to investigate and check out. Feel free to contact me at any time. My name again is Bill Schwan, And my email address, william.schwan@flir.com. Email me anytime. Anytime I can be of assistance to you. And I think I'm ready to turn this back over to Matt. Hey, Matt.
Let me see, Bill. I'll leave up that slide there with the email and just back up the question list just a bit. Had a couple that I answered during the presentation, but a few more that came in here at the end from Terrence was asking, Terrence, what height do you recommend to fly at if you're using SUAS?
Hey, Terrence, that's a great question. You know, there's a couple of different ways to look at this, and that is it depends on the height of the structure. The FAA 107 says we can't fly any higher than 400 feet above a structure. Of course, that also means that we can't enter another flight zone or another area. So the important thing to know is that I like to try to get one image of the entire roof if I can, and then identify areas that there might be challenges and drop down. I like that 50-foot area. At 50 foot above the membrane, you can get great images, especially if you have a 640 by 512. Hope that helps, but feel free to email me if you have any other questions.
James was asking if the two-day class has a certification associated with it. You've done a couple of those two-day classes, right? Bill, what do we offer with that?
Yes, what we offer is a verification of completion. It's not really a certification, and the reason behind that is that we do follow ASTM standards and American Society for Non-Destructive Testing standards, which basically requires 32 hours. So that's pretty hard to get in a two-day course. So we do offer a verification of completion for continuing education units or for your records or for you to present to your client.
And just like AS&T, it's an employer-based. There is no central licensing or required certification for roof inspections, just like handheld IR, right?
That's correct.
Okay.
That's correct.
Let's see. Stephanie was asking, have you seen success in scanning ballasted single-ply membranes, or do you find the stone interferes too much?
There is some success, but it takes a lot of patience, Stephanie. It takes angle. If you get a ladder and you get on the correct angle, all the conditions are right. In other words, solar loading is completely off the membrane. You have a clear, cool sky. You can get some success. Also depends on how deep is the ballast, how large is the ballast. So it's a hit and miss, but I have done it and I have seen some success with it. But there's a lot of factors and everything has to line just right, Stephanie. So hope that helps.
Looks like Justin was asking for a commercial inspection. If you were seeing a large difference in the seam from a lower level part of the roof to another higher section, would this be a sign of heat loss or infiltration? I guess, how do you discern between what's, issues with building envelope performance versus moisture bill?
Justin, good question. Usually moisture performance issues are going to be non-symmetric. So if we have insulation issues, you'll see gaps in the insulation, in other words, straight lines or blocks of missing insulation in the foam underneath. Or if there's insulation in the member or insulation underneath the roof deck, again, it's usually not, moisture is not going to be symmetrical. So that sometimes it's a challenge to tell the difference. But the other way to tell that difference is to use other methods. In other words, use a moisture meter, non-penetrating, to see if it's moisture or heat loss. That's my advice.
From Terrence, again, he was wondering if there's a ballpark. I know, Bill, you've worked with a lot of these outfits. Is there a ballpark charge for doing a roof inspection with aerial IR with a drone? What are the operators charging typically? Do you have an idea from what you've heard in your travels?
Terrence, we're hearing anywhere from $1,100 to $1,700 per day, and that just depends on the region or the area that you operate in. Some areas are less, some areas are more, but that's what we're hearing, anywhere from $1,100 to $1,700. That's what I'm hearing from the operators when I do a course.
Scott was asking about the ideal time to wait after solar loading for an SUAS inspection. Now, there are considerations for windows that we have, Bill, right? With the regulations that are out there. What's the window? When do we go up and do an aerial IR scan of a roof?
Right. Great question here. Remember, FAA 107 says we have 30 minutes after civil sunset. So without a what's called daytime waiver, yes, it sounds weird, but a daytime waiver actually allows us to fly at night. So you've got basically 30 minutes after civil sunset in order to not need an additional waiver. So you've got that 30-minute time period. Remember, it doesn't always have to be after the sun is set. It just has to be with no solar loading on the roof. So I hope that one helps too.
Stuart's asking a common question that we get, and it's about do we not require moisture to have been present on the roof? I guess in order for the inspection to be possible, meaning, we need a source of moisture, obviously, for moisture leaks to show up. I guess, Bill, from your experience, with roofs, it could have rained 3 weeks ago, and the roof could be bone dry in terms of the surface. That water stays in that membrane for quite a while, doesn't it?
It does, Matt, but the other thing, Stuart, is that this water will, of course, evaporate. And so we need water to be on the roof. In other words, we need it to rain, but then we have a period of time or a window where we have to make sure there's no water on the roof for us to do our evaluation. So again, if it's 3 weeks, depends on mass. How large is the roof leak? If we have a very small leak, that could easily dry itself out. If we have a large area, that could retain longer. So it's really a challenge to determine how long to wait after a roof membrane is after a rain. I like to try to get on it as quick as I can, and just right after there's no water on the roof, so that I can find the entire area that might be moisture underneath that membrane.
We had a question from Jeff about, is the 2-day course online? Not at this time, Jeff. We don't have an online version of that 2-day class. It's a 2-day in-person class. I know with the SUAS classes, Bill, they can, given we've got the right location, there's some flying involved also, correct?
That's correct. And that's a 4-day course. The SUAS course is a 4-day course, and we have 2 afternoons of actually getting the vessels up in the air so that you can take a look at what the image looks like with different cameras, and that you can also get used to the app so that you know how to take the images correctly. And yes, there is some flying involved with the 4-day SUAS course.
Looks like James was asking about exactly that. Do we offer a 4-day roofing course? Would that be your recommendation, that he looks at that particular class, the SUAS level 1?
Yes, if you were looking for a certification, it would be the level 1 SUAS course. Of course, we don't only look at roofing, we look at solar panels, we look at agriculture, we look at a lot of different applications in that course. We even look at oil and gas. So there's a lot of different application in that 4-day course.
I'm thinking that if you're running an SUAS platform, it's, you're learning the technology. That's probably not a bad thing to not only get the roof training, but also get the other application training, I would think.
Gives you a lot of diversification.
Yeah. Let's see. Who else was asking here? Scott was asking about the waivers. And I guess, can you just chat briefly about the waivers, Bill? How do you go about getting a waiver? What's that process? Websites, resources, things like that?
Hi, Scott. The waivers would be, you have to, of course, a couple of prerequisites. One, you have to be an FAA 107 pilot. Number 2, you have to have the vehicle registered or vessel registered. Those are the 2 things that you'll prerequisites in order to go to what's called the drone zone. www drone zone. You put in the registration, your FAA 107 certification number, and then it allows you to apply for the waivers. If you go to FAA.com/waivers, it'll give you all the prerequisites for the different waivers for what's called the daytime waiver, allowing you to fly at night. A waiver for flying over people, that's a waiver as well. There's also a difference between waivers and authorizations. An authorization might give you permission to fly within the 5-mile zone of an airport. So our recommendation is go to FAA.com/waivers and just research the different waivers. You can also go to the Drone Zone, which is a FAA website, and it'll show you the different waivers there as well.
Let's see, James was asking about a list of aerial IR contractors. Do we have that available? I don't believe so. Not that I'm aware of. Jeff was asking about solar loading. And the definition of solar loading, Jeff, is just basically the sun charging a surface, heating up a surface, whether it's a roof, a wall. Solar loading, solar gain. That's energy, BTUs of heat that are causing the roof surface to heat up. That heat transfers into the insulation. Where there's wet insulation, takes on more heat. Where there's dry insulation, takes on less. And so the wet insulation stays warmer longer in the evening after sunset. And so that solar loading is what makes that roof inspection possible. Scott asking about a level 2 SUAS bill. Have you heard any chat about that? I'm not aware of that. Is that something that is coming down in the future?
Jeff or Scott, that is a good question, and that is something that has been in discussion. And keep an eye out for that. Check in with us because it looks like we might be headed that direction, maybe second quarter 2019 at this point. One of the classes that we're also right in the middle of class development on is a public safety course for law enforcement, firefighters, search and rescue. So keep your eye out on that. That'll be coming out first quarter 2019.
Adam was asking about an SUAS course for Canadian thermographers. Anything up in Canada that we have available at this time? Do you know of, Bill?
Not that I'm aware of. We've been getting a lot of students actually from Canada coming into our courses. I'm seeing 1 to 3 per course. From Canada, but I'm not aware of any courses in Canada at this time. Of course, the Canadian standards are completely different from the U.S. standards in that they're quite stricter, actually. So I encourage you to research the standards in Canada prior to taking the course.
Message or a question from another Scott here. The best time of day for solar panel inspection, Bill?
You know, solar panels are quite different. They have to have a specific amount of watts per meter per square foot in order for the solar panel to fully absorb. Also, we can't have too many clouds. In other words, we can't have any more than 2 to 8 cumulus, which means that 8 to 8 would be full cloud cover. Anything more than 2 to 8, we're not going to be able to see all the thermal anomalies. We need about 600 watts per meter squared. So you need a light meter to really tell that you've got the right absorption. Of course, with a solar panel, if we see a thermal anomaly, it's usually square, and that's where the solar cell is no longer transferring the information or transferring the energy, it's retaining it. So 600 watts per meter squared on the amount of energy, and of course cumulus, no winds. Winds should be less than 15 miles per hour. So just some standards on solar. Time of the day, you know, any time really during the day, as long as those standards are met, will work.
We'll take a couple more questions here, both from 2 different Scotts. Scott C was asking about the, he's got his 107. What's the ideal time to wait? I guess it's a good question, and Scott, if I misrepresent this, let me know. But I'm always curious too. You've got this sort of twilight window that we can work in the evening, Bill. But you know how that window doesn't necessarily always open at that time. What is the ideal time to wait after that sun comes off that roof? I mean, it varies, doesn't it? It's not always cut and dry that it's exactly 30 minutes or whatever. I guess, what do you do about that? Or, what's the window for those that are doing, these evening inspections?
Exactly, Matt. It's not always cut and dried. It has to do with a lot of things. And one of those things is, hey, do I have cloud cover? Cloud is an insulator to the sky, which means that I'm not going to get the delta T I need, even though it is well after dark. Or maybe I have a cool, clear sky, and the sun just came off the structure and there's no solar impact on the structure anymore, I've gotten good results. And it isn't even after that 30 minutes after solar or the solar sunset. So, the thing to keep in mind is it's not cut and dried. It's experimental, and it's challenging. So, I've done it at 4:30 in the afternoon. I had a 10-story structure on one side. I was working on a 3-story structure, and that roof was no longer had solar impact, direct solar impact, and I've had results. So, like you said, Matt, it's just not cut and dried.
Let's see. Last question we'll take from Scott asks, ever good time to use IR on metal roofs? What's your what's your perspective on that?
Infrared on metal roofs, I have not had any success with this, Scott. And the reason behind that is that the metal is quite reflective. So if there's moisture underneath the metal, it's not going to be emit through the metal like a membrane. So performing it on metal roofs is, I've not had success with that, Scott.
All right, we'll wrap it up. Thanks again for joining us, folks. Again, we've got it recorded here. We'll play it back, put it up on infraredtraining.com/webinars here in the coming week or so. And of course, there's other topics that are available there as well. Appreciate your time today, Bill. Thanks again.
Thank you, Matt.
And thank you for joining us, everyone. We'll see you back online again here this afternoon at 2 o'clock with Scott Sammons using the top 5 IR applications or top 5 uses of IR in building systems. That's at 2 p.m. Eastern today. Hope to see you online then. Take care. We'll talk to you soon.